Hello everyone, very good evening one and all. Welcome to the most comprehensive preparation platform for all competitive exams, BYJU'S Exam Prep. And warm welcome to all dear NIELIT aspirants. Join the session quickly. This session is going to be very useful and unique session because this one session will give you all in one formulae which are very useful in the NIELIT exam. In this session, I will give you 5 subjects formulae. These 5 subjects, in fact, actually it is a 6 subjects. These 6 subjects formulae will give you nearly around 40 plus marks. So, why late? Join the session quickly. Also, share the session link to your friends because this is a very useful session. Let this session benefit as many students as possible. Okay, so all dear friends, please confirm my visibility and audibility. Am I visible and audible clearly or not? Please confirm. Let us get into the session after your confirmation. So all-in-one formulae for NIELIT aspirants. Download our BYJU'S Exam Prep app if you have not downloaded it. There are very useful features like leaderboard where you can check your rank among your peer students. And guys, our BYJU'S Exam Prep is conducting the national scholarship test for the GATE exam, through which you can avail up to 90% off on all our programs, and the upcoming scholarship test is on 5th November. So do enroll. Even for NIELIT aspirants, it would be useful. You also can enroll, register for this scholarship test. And our expert, Mr. Abhinav Negi sir, will be conducting a live interactive workshop for 2025 GATE aspirants, blueprint to be a topper in GATE 2025. So, sir would conduct this live interactive workshop on 1st November, that is tomorrow at 7:30 p.m. Very useful workshop, guys. Register for the same. And this is the complete schedule of All India Open mock tests conducted by BYJU'S Exam Prep for GATE 2024 computer science aspirants. Even for other branches also, these All India Open mega mock tests are happening. For CS, this is the complete schedule. You can get this even on our app or website also. Okay. And yes, guys, for 2024 aspirants, as there is hardly 3 months time, so there is a crash course which strengthen your practice with more of questions. And for 2025 and 2026 aspirants, there is a long-term course called Vision Gate 2025 and 2026. So you will get everything and more than that you required in these courses. So enroll for these courses and avail the benefit. Yep. So to start with, if anybody are new for my class, you can find my quick details here. I am Satyanarayana Kaitepalli. I am a research scholar with all the other credentials. Now in this session, as I said, I will be covering 5. In fact, in the NIELIT syllabus point of view, it is 6 subjects. What are they? Computer networks, programming and data structures, algorithms, operating systems, and computer organization and architecture. So these 5 programming and data structures is actually a separate subject, 2 different subjects in the NIELIT syllabus. Henceforth, it comes around 6 subjects for NIELIT aspirants. So these 5 or 6 subjects formulae are important points or direct questions from which you can get. Those we will be covering. Okay. So are we ready? Can we get into the session? Everybody, are we good to go? Please type go in the chat box. Please type go in the chat box. Shall we start the session? Come on guys, be interactive. Yes. I want the go message from everybody, whoever are watching it. Come on guys, don't be lazy. Thank you Amigo, thank you Ved Prakash Sahu. Okay, no issue. So let us start with computer networks first. As I said, in this session, formulae means, please understand the important points from which you can get the direct questions or a quick revision of very important concepts. Okay, so from computer networks, first of all, you have to definitely go through the layers of OSI model. What are the layers of OSI model? We have application, presentation, session, transport, network, data link, physical. This layer numbering is very important. Application being 7, presentation 6, 5, 4, 3, 2 and physical layer being layer 1. At sender side or receiver side, layer numbering would be same. This is very important point. And their functionalities, as you see in one sentence, application layer will allow access to the network resources. It acts as an interface for you. Presentation layer is responsible for encryption, decryption, translations, compressions. Session layer is responsible for dialogue control to establish and manage the session. Transport layer is responsible for reliability and end-to-end communication. Network layer is responsible for routing, IP addressing. Data link layer is responsible for error control, flow control, hop-to-hop delivery, framing, MAC addressing. Physical layer is responsible for encoding or decoding, and this, what we say, to deal with the physical medium, right? So please go through this. Please go through these 7 layers and their functionalities. And at application layer, we call the data as message. Presentation session layers we call simply as presentation protocol data unit, session protocol data unit. At a transport layer, we use the term segment, or we can use the term datagram. If we are following TCP, we use the term segment. For UDP, we use the term datagram. At network layer, we call it as packet. At a data link layer, it is a frame. At physical layer, it is bit. So this terminology is also very important. Definitely Sudeep, why not? And Manishankar, please drop an email. First ping me in the Telegram group. I will give an email ID. Please drop an email to that. Kam ho jayega. Okay. And now the terminology, as I said, at each layer, what we call the data as is very important. And when it comes to TCP IP protocol suite, we know that 7 layers are formed as 5 layers, means application, presentation, session layers are merged into only one layer, that is application layer, right? So at TCP IP, you have to definitely remember the protocol mapping, at which layer what protocol is applicable. Like at application layer, protocols like Telnet, FTP, SMTP, DNS, RIP, SNMP, HTTP, HTTPS, POP, these kind of protocols will operate at application layer. And transmission control protocol, user datagram protocol, and SCTP, stream control transfer protocol, operate at a transport layer. Routing protocols and inter-networking protocol and error reporting protocol like internet control message protocol and internet group message protocol for multicasting, and for address mapping, ARP, RARP, these operate at the network layer. And at the data link layer, you can say sliding window protocols, And the standards like Ethernet, token ring, frame relay, ATM, these are related to data link and physical layers together. And then in the computer networks, you have to first remember and learn what are different types of delays. To send data from one node to another node, the total time taken is what we say network delay. That network delay is comprising of 4 types of delays. If I take the network delay as T, let's say capital T, this is summation of transmission delay, propagation delay, queuing delay and processing delay. Transmission delay is the time needed to push the data into the channel. Propagation delay is the time taken to reach the destination. Queuing delay is the time waiting for the node to get processed, and the time taken to process, maybe to add header, trailer, we can call as processing delay, right? And now, how do you calculate transmission delay? As I said, it is the time taken to push the data into the channel. So it depends on channel's bandwidth and the data size. So TD is calculated as packet size divided by bandwidth. Very, very important point. And propagation delay is calculated as length upon speed, means the channel length between sender and receiver upon propagation speed, right? And then you have to quickly go through this. Give me a moment once. Yeah, you have to quickly go through these IEEE standards. IEEE standards, because just on this also a question can come in the NIELIT exam. IEEE 802.1 is formerly known as internetworking. 2 LLC, logical link control. 802.3 Ethernet, 802.4 token bus, 5 token ring, and then must and should 802.1 Wi-Fi or wireless LAN, 802.15 Bluetooth. So at least these 7 standards and their technical names, please remember. And in the Ethernet again there are substandards. 802.3 U, Z, AB, AE. So U is for fast Ethernet, which is 100 Mbps speed. Z is for gigabit Ethernet over fiber optic or coaxial cable, and AB is gigabit Ethernet for twisted pair cable, and AE is for 10 gigabit Ethernet. These terms are also very important. And 802.3 or Ethernet frame format. Here as you see, the minimum frame length is 64 bytes and maximum frame length is 1518 bytes. What is a frame? Frame means not only data or payload, it is header, payload and trailer together. So here frame check sequence or trailer is what, CRC is what trailer, while destination address to length is header, and this is data. So if you look at the destination address, source address, length, header part is of 14 bytes and trailer CRC we have 4 byte trailer. That means including header and trailer 18 bytes gone. So what is the payload range? Payload range in the Ethernet 46 bytes to 1500 bytes. So the minimum payload in every frame must be 46 bytes and maximum payload must be 1500 bytes. Okay, definitely Manishankar, I will share the PDF in the Telegram group, don't worry. Abhishek Kumar, please ping me in the Telegram group, I will share the mail ID. When you mail to that, your extension will happen. Okay, right. So Ethernet frame format, dear friends, please do revise once. And here one more point, what is the start frame delimiter 1 byte sequence? It would be what? 10101011. In the Ethernet, these 8 bits would be 6 101010 followed by 2 ones. Okay, and the preamble 7 byte or 56 bits would be alternated ones and zeros. So 28 ones alternated by 28 zeros. Okay, that is also important. And now, once you are expected to recall quickly the sliding window protocols. We know go back and selective repeat or selective reject, stop and wait ARQ, these three are for flow control in the at the data link layer. Here the efficiency or you can say it as utilization can be less or equal to window size divided by 1 plus 2a. What is a? Propagation delay divided by transmission delay. And what is W? Window size. What is window size? Sender window size. I can say sender window size. In stop and wait, sender window size is 1. That's why it is 1 upon 1 plus 2a. In the go back n, sender window size is capital N, that is 2 to the power n minus 1. In the selective repeat, it is 2 to the power n minus 1. 2 to the power n minus 1. So here, what is the maximum number of sequence numbers required? This is very, very important point. Here in the stop and wait, sender window size is 2, receiver window size is, sender window size is 1, receiver window size is 1. So maximum 2 numbers are required. In the go back n, sender window size is capital N, receiver window size is 1. So total n plus 1 maximum sequence numbers are required. In the selective repeat, 2 into n, that is 2 into 2 to the power n minus 1, that is 2 to the power n sequence numbers are required. Here also 2 to the power n sequence numbers are required. Okay, because capital N means what I have written clearly. So these are very, very, very important points, guys, on which you will get direct questions, or this formulae will be very useful to solve questions. And then without fail, please do recall IPv4 header format. Every field is important. From any field a question can come. Here if you see the length of every field, version 4 bits, header length 4 bits, HELEN, actually this is HELEN. HELEN value multiplied by 4 when you do, you will get actually header length in bytes. Header length in bytes. Okay. And this minimum header length in IPv4 is IPv4 header length has a range. Minimum header length is 20 bytes and maximum header length is 60 bytes. That means you have 40 byte optional header in the IPv4, even in the TCP also. Okay. And here you see in the flags there are two flags MF and DF, or simply M and D. When M or MF is set to 1, 0, that means it is the last fragment. Okay, very, very important point. And what is total length? Total length is summation of header length and payload length. So you may get question asking for the payload length by giving total length and HLEN value. How do you get header length when HLEN value is given? Multiply with 4. That is header length given total length. So you can easily get payload length, right? And now what is this fragment offset? Fragment offset is a 13-bit field. How much? 13-bit field. And this indicates the starting sequence number. The starting sequence number of payload divided by 8. That means offset value multiplied with 8 when you do, you will get the starting sequence number of payload in that particular fragment. Okay, and you see TTL. What is this TTL? Time to live. Time to live. Why this TTL is for? To prevent packet looping. If a packet visit any node more than one time, means the same packet came to the node, automatically TTL value will be discrepant. Accordingly, packet rejection or packet drop occur. So to prevent packet looping, this TTL is used, and it is a 8-bit field. But it is not an incrementing counter, it is a decrementing counter. So the TTL value may be initialized to 255 or less, and the minimum TTL value is 0. Before TTL value becomes 0, the packet should reach the destination. Okay, so TTL value should be non-zero while reaching the destination. Even when TTL equal to 0, packet reached the destination, destination discards the packet. Okay, so all these points you have to go through. And now IPv4 addresses. Guys, from this definitely you will be getting a question in the NIELIT exam. I can say you will get 2 or 3 questions. There is a scope. 2 questions or 3 questions you may get from the IPv4 addresses. So IPv4 address length is 32 bits. These 32 bits are actually represented by separating each 8 bits with the dot symbol. So in each byte you can have any number from 0 to 255. Henceforth, you will get several combinations of addresses. So the starting IPv4 address number will be 0.0.0.0. This is what we say global DBA address, and the last IPv4 address will be 255.255.255.255. This is what we say global broadcast address. Sorry, the first one is not a DBA. This is what DBA. The first one is global network interface address. And the last one is global DBA or global broadcast address, direct broadcast address. And there is one special address called loopback address for self delivery of packet, that is 127 dot. If it starts with 127, any other value you can say as loopback address, and our region use 127.0.0.1 as loopback IP. However, if the first number is 127, you can say it as a loopback address. Okay, and the remaining addresses are actually grouped into 5 groups, A, B, C, D, E, in which class D addresses are used for multicasting. Class A address range you see 0.0.0.0 to 127.255.255.255, and class B 128 starting number to 191. Remaining 3 numbers can be from any number from 0 to 255. Class C 190 to 223, D 224 to 239, E 240 to 255, and the last number is excluded here. First number is excluded in class A. Okay. So there is a possibility that by giving certain IP address, you may be asked to which class this IP address belongs to. So always focus on the first octet value. Class A 0 to 127, B 128 to 191, C 192 to 223, 224 to 239, 240 to 255, like this. And it is very important to also go through this subnet mask and host per network and number of networks. In class A, for network ID, the first 8 bits are reserved. For the host ID, last 24 bits are reserved. And for class B, 16 bits represent network ID, 16 bits represent host ID. In class C, 24 bits represent network ID, 8 bits represent host ID. Accordingly, as per the range, how many networks are possible? In class A, 2 power 7, B 2 power 14, C 2 power 21. Number of hosts, first and last host IDs are always reserved. So, among the total possibilities, we will subtract 2. So, this is what IPv4 addresses range, number of networks, number of hosts per network, subnet mask. So, please do revise this without fail. Very, very, very important, dear friends. Okay. And along with that, TCP segment format revision is suggested for safe side. Again, TCP segment range is also 20 bytes to 60 bytes. Means minimum length would be 20, maximum would be 60. That means there is a optional 40 byte header, and the length of each field in the header, sequence number 32 bits, TCP sequence number, port number whether it is source port or destination port 16 bit, acknowledgement number 32 bit. Okay, checksum 16 bit, urgent pointer field 16 bit. So guys, please do remember the lengths, because you may get a question match the following by giving the field and the length. Okay, and port numbers and their names. What is the port address length? Port address length is 16 bit. That means total 2 power 16 or 65,536 ports are possible. These are divided into three groups: well-known ports, registered ports, private or dynamic ports. Well-known ports you can also call as contact ports or universal ports. The range is 0 to 1023. And how many well-known ports are there? 1024. And from 1024 to 49151 are registered ports. So total 48,128 registered ports will be there. And 16,384 well-known dynamic or private ports will be there. So please do remember this range. Okay, all protocols will have well-known ports or contact ports or universal port numbers. Their numbers you see: FTP data, port number 20, FTP control, port number 21, SMTP, 25, telnet, 23, DNS, 53, HTTP port number is well known, very much popular, that is 80, POP3, 110. These are very, very important port numbers. In these, DNS port number is UDP port number. Other you can say TCP. Even telnet is also TCP based protocol. Okay, TFTP, DNS, you can say UDP protocols. And you can also remember the protocol IMAP port number 443 or 143. I think 143. 143. It is also TCP protocol. Okay. Now, let us switch to programming and data structure subject. In this, we have very less formula, but important. Firstly, with arrays and pointers, I am directly giving the consolidated formula kind points. Let A be an array, P be a pointer pointing to an array. If it is one dimensional array, when you say A of I or P of I of A or I of P, that will give you value at index I. When you mention it as A plus I or I plus A or P plus I or I plus P, address of value at index I. That means address of A of I. But if it is a two-dimensional array, it is a slight different, because two-dimensional array is array of one-dimensional arrays. So, if you use A plus I or star A plus I, that both gives you ith row address, because A plus I here it is a array, star of A plus I is a pointer pointing to whole array. Array is a constant pointer, no? So, both gives the base address of ith row. When you say star A plus I plus J, then you will get address of ith row jth column, and if you use a double star, you will get value at I and J. Okay, this is a very simple one. And with arrays, you may be asked to find the address of element at so and so index. That also I am giving. So, for one dimensional array, if the index starts from 0, address of x of I is b plus I into n, where b is base address and n is scale factor or size of each element. in bytes. You can also call it as scale factor. If the index starts from 1, you say I minus 1. If the index starts from j, you say I minus j. So let me make it as k. So I minus k you can use. Index can start from any number, minus 2, minus 3, etc. Then you use just simply I minus k. For 2D array, we know 2D array can be saved in row major or column major. Languages like C, CPP, Java follow row major order, while language like Fortran follow column major order. You may be asked any in the NIELIT exam to find the address of 2D array element. So two-dimensional array address element, two-dimensional array element address is b plus I into c plus j whole into n if it is row major order, where I is row index, j is column index, r is total number of rows, and c is total number of columns. As usual, n is size of each element and b is base address. If the index starts from k, then you can say I minus k, j minus k. Okay? Now, directly switching to trees concept, data structures. There are several formulae which are very important in the data structures, that is trees. First, in a perfect binary tree at level L, number of nodes will be 2 power L if the level numbering starts from 0, 2 to the power L minus 1 if the level numbering starts from 1. And the number of unlabeled binary trees you can form with n nodes is the nth catalog number, that is 2n cn by n plus 1. If it is labeled, 2n cn by n plus 1 into n factorial. And the maximum height you can form with n nodes is n minus 1. Minimum height is log n plus 1 base 2 minus 1. Minimum height you will get in perfect or complete binary tree. Maximum height you will get in skewed or degenerated binary tree. Vice versa, to form binary tree with height h, minimum nodes required are h plus 1. This is in a skewed or binary tree, skewed or degenerated binary tree. And maximum nodes required are 2 power h plus 1 minus 1, that is in perfect binary tree. And if suppose there are x leaf nodes, number of nodes with exactly 2 children would be x minus 1. Definitely Shiv, I'll share in my Telegram group. Okay. So as I said, programming data structures has just few formulae. So quickly moving on to algorithms. Firstly, you have to learn master theorem. We have master theorem for two cases, for exponential decrease in the input size, for linear decrease in the input size. So if the recurrence relation is of this form, then we extract a, b, p and k values and we will match, we will see whether these constraints are matching or not, constraints are satisfied or not. If the constraints satisfy and the recurrence relation is in this form, then we compare a and b to the power k value. As per the satisfaction, we can directly represent its time complexity. Guys, please do practice this master theorem. It saves a lot of time, and I can say minimum one question you will get from this recurrence relations to solve. If you learn master theorem, Just like that you can answer the question and you can give the correct answer. Okay, do writing practice of this master theorem. Just 10 minutes effort would be enough, guys. At least before you go for the exam, have a writing practice of master theorem once, at least one day before. Very, very important. Very, very important. So this is the exponential decrease in the input size. If there is a linear decrease, means every time the n size, input size is decreased by b, then we will make sure the constraints satisfy and compare a value. Accordingly, you can write the time complexity. And here I am presenting various time complexities. Big O of 1 is called constant time complexity, which is the minimum time complexity, and exponential time complexity, big O of 2 power n, even than this n to the power n is bigger. N to the power n is bigger, right? So constant to exponential, you see the time complexity and their name. And for all searching algorithms, what is the time complexity? Here I have consolidated for you. Linear search n, binary search log n. At least you remember these two time complexities. And then depth first search and breadth first search, which is order of vertices plus edges, number of vertices plus edges. At least these 4 time complexities, please try to remember. Also, sorting algorithms time complexities. You will get a direct question, guys, on this. With respect to case, please remember best case, average case, worst case. It is very easy. Heap sort and merge sort have time complexity of n log n in all the cases. So heap sort time complexity, merge sort time complexity same. Quick sort has n square time complexity in the worst case, in the other cases n log n. Similarly, selection sort, bubble sort and insertion sort time complexities are also same. N square, in the best case I think it should be n. Okay, it is given modified bubble sort. Fine. So bubble sort, modified bubble sort and insertion sort time complexities would be same. Best case n, other cases n square. Selection sort, all cases n square. Please do remember these time complexities of sorting algorithms. You will get a direct question. And for you, I have kept the time complexities of all the data structures, dynamic programming applications, problem and their time complexity, greedy applications, their time complexity, divide and conquer applications, their time complexity. For your reference, I will share this PDF in the Telegram group, so do go through it. Okay. Also, I have kept the recurrence relations of most popular applications, most frequently asked applications in the exam. Quick sort, average and best case time recurrence relation is T of 2t of n by 2 plus big O of n, whereas worst case recurrence relation is T of n minus 1 plus big O of 1. This is most frequently asked recurrence relation. Also other recurrence relations you see, merge sort, binary search. Okay. Now moving on to operating system subject. In this, firstly you have to remember this CPU scheduling formulae. One is turnaround time, waiting time, response ratio. How do you calculate turnaround time? Completion time minus arrival time. And how do you calculate waiting time? Turnaround time minus burst time. Response ratio, burst time plus response time whole divided by burst time. These three are very, very important in CPU scheduling. Hope you know the CPU scheduling algorithms are classified into two types: non-preemptive and preemptive. Non-preemptive are first come, first serve, or first in, first out, you can say. HRRN, highest response ratio next, shortest job first, non-preemptive priority. While preemptive are round robin, preemptive SJF, which is called SRTF, preemptive priority, multi-level queue, and multi-level feedback queue. Okay, and then please remember the formulae in paging. This is important. How do you calculate number of page table entries? That will be equal to number of pages. How do you calculate number of pages? Number of pages will be process size divided by page size. Okay. And how do you calculate page table size? Number of pages or number of page table entries, both are same, multiplied by page table entry size. And optimal page size, this is very important, which is a square root of 2 into process size into page table entry size. Okay, Shubham, don't worry dear, I am always with you. BYJU'S exam prep will be always with you. Yeah. So these three are very, very important. Along with that, effective memory access time. Without page fault, with page fault. Without page fault, it is hit ratio into T1 plus T2 plus 1 minus H into T1 plus K plus 1 into T2. Here, what is T1? TLB access time. And what is T2? Main memory access time. And what is K? Number of levels of paging. And what is H? Hit ratio. And with page fault, it is 1 minus P. What is P? Page fault rate or fault ratio. And here T3 is, I am directly taking it as page fault service time. And EMAT1 is this one. Page fault, EMAT without page fault, I am taking as EMAT1. Okay. Now, just to remind you, this is very simple, but generally we confuse in hurry. When a wait operation or P operation is applied on a semaphore, semaphore value will be decremented. And signal or V operation is applied, it is incremented. It is known to everybody, very simple, but in hurry, generally people confuse. So, just to remind you that I have included it here. Okay. And finally, computer organization and architecture. Relatively, there are multiple formulae here. So, firstly, in the instruction pipelining, we have several formulae. As you see, non-pipelined time you calculate as number of instructions into number of stages into stage time. Pipeline time as n minus 1 plus k whole into stage time. And cycle time in non-pipelined execution is sum of stage delays, while in pipelined execution it is max of stage delays plus interstage delay. Total time for execution, if you are given with cycles and cycle time, cycles per instruction into cycle time. And how do you calculate speed up? Always non-pipelined time divided by pipeline time. What is the maximum speed up or ideal speed up you get? Number of stages. Efficiency, speed up upon number of stages. Throughput, n divided by pipeline time, number of instructions divided by pipeline time. And frequency, 1 upon cycle time, that is f is 1 upon small t. So, these are what important formulae in instruction pipelining. And then in the cache memory, definitely you have to go through this mapping techniques. What is maintained as a tag, where there are conflict misses high, less 0, hit latency high, less 0, all this please go through. Okay, in the direct mapping, in the direct mapped cache, interpret the CPU generated address as tag line word. Here line, block both are same. But if it is associative, just maintain it as tag word, and if it is set associative, tag set offset and word offset. And in the secondary memory, if you are given CHS, how do you calculate sector number? This is again many will not give it. So, this is like a shortcut for you. Sector number you can calculate as cylinder number into total surfaces into sectors per track plus surface number given into sectors per track plus sector number yes given. And also access time T is a summation of seek time plus average rotational latency plus transfer time plus controller's overhead. Rotational latency will be half of one rotation time, right? And in the IO interfacing, if X is the time, CPU use the bus, Y is the time, controller use the bus, CPU idle time and CPU busy time in percentage you can calculate like this, Y by X plus Y into 100 or X by X plus Y into 100. Okay. So, these are all what different formulae I can say from these 6 different subjects. These 6 different subjects formulae, if you can remember, along with mathematics, definitely will have so many formulae. Definitely you will get easily 80 marks, easily 80 marks you can get. Okay. So, prepare well, all the very best. I will share this PDF in my Telegram group. My Telegram group link is Satya_CS Guru. If you type in the Telegram, you will get my image. You can join. Tomorrow morning, I will share the PDF. Okay. Hope this session is useful for you all. Is this session useful? Please do respond. Great. I will share the PDF tomorrow morning. If not, someone please remind me in the Telegram group. I mostly share it. If at all I forget, someone please do remind me. I will share. Okay. And guys, before you leave, try sharing this session link to your friends, because many other people might be looking for this such consolidated document of formulae and important points, no? So if you help others, God will help you. So don't be selfish in this sharing of the knowledge. Try to share this session link to your friends and also my Telegram group link. Okay, thank you so much guys, and I'll come up with more useful sessions for you from the next week. I think not from the next week, from Monday, from tomorrow itself. I think I'll bring top 30 questions of algorithms for you guys. So at 9 p.m. in this week, going ahead, my classes will happen at 9 p.m. So try to attend all the classes regularly. I'll share the notification in my Telegram group. Keep learning, keep growing guys.